Alright, welcome back. In this lecture, we're going to continue learning the basics of MATLAB by looking at vectors. So we're going to learn how to create numeric vectors in MATLAB. We're going to perform basic vector operations, and we're going to write mathematical expressions using functions on an entire vector. So vectors consist of numeric values organized into a single row or a single column. These are slightly different than how you would think of a vector in terms of having a value and a direction. So for example, 3.5 minus 38, 0, minus 1, or minus 1, 0, 3.2 are examples of a row or a column vector. They're either an n by 1, which is a column matrix, or a 1 by n matrix, which is a row vector. So we went from scalars, which were a 1 by 1, to now a 1 by n or an n by 1. Basically, we're just putting more values in something. For example, the reason we think of them as vectors is because if you break down a force into its x, y, and z components, that's where you would store them. As with scalars, vectors can be defined using our assignment operator, the equal sign. But how do we tell MATLAB we are defining a vector and not a scalar? How do we tell MATLAB whether we are creating a row or a column vector? How do we distinguish the individual values from each other? Well, it's fairly simple. So when we're defining a vector, the first character following our equal sign is an open square bracket. This tells MATLAB I am defining a vector or matrix, but we'll get to that later, and not a scalar. Once all the values have been entered, again, I'm going to end by closing a square bracket. So numbers have to be spaced out using delimiters. You can use a space or a comma to create a row vector, and a semicolon to create a comma vector. So if I type in pair equals open square bracket 23 space 4.3, my variable pair is going to contain the row vector 23 and 4.3. If I define a vector called trio, and I say trio is equal to open square bracket 1, 4, 7, 9, 8, 5, 7, I close my square bracket, the variable trio is going to contain a row vector that has the values of 1, 4, and 79,857. If I want to create a column vector, I'm going to define a variable called ctrio, and that's going to be, if I define a variable called ctrio equals open square bracket 0, semicolon 0, semicolon 97, close my square brackets, I want to create a column vector. So the semicolon tells MATLAB to go to the next row. There's also a very useful operator called the transpose operator, which is the apostrophe. It can convert a row vector into a column vector or a column vector into a row vector. Sometimes it's called a glitch in the book. So if I have a variable that I've defined v, and v is equal to 6, 9, 6, minus 9, 3, that's a row vector, and I define a second variable vt to be equal to v apostrophe, vt is going to contain a column vector of 6, minus 9, 3. So I've switched the rows and columns in my vector to go from a row to a column. MATLAB can also create linear sequences to create a vector containing a set of equally spaced values. That's a linear sequence. A very useful shortcut in MATLAB is to use the colon delimiter. So if I define a variable that's the linear sequence equals 1, 5, I'm going to create a sequence that contains, I want to create a variable lseq, which contains a vector that has the values of 1, 2, 3, 4, and 5 in it. If I want to create a sequence that goes in increments other than 1, you place the increment between the first and last value. So if I create a variable that has, I'm going to call it lseq A, and I say it's 5, 15, 80, that means MATLAB is going to define a variable that contains the values from 5 to 80 in steps of 15. You can also do fractional increments, and you can do negative increments. Let's look at a quick example. So what will be in V1 following the execution of the following line of code? My line of code is V1 is equal to square bracket 25, 25, 125. Well, MATLAB is going to create a variable V1, and in it, it's going to store a sequence that goes from 25 to 125 in steps of 25. So that is 25, 50, 75, 100, 125. What about this one? So I type in the MATLAB v3 is equal to 5:3:16. What is MATLAB going to do? Why don't you pause the video here and think about it? Well, MATLAB is going to create a vector that goes from the values of 5 to 16 in steps of 3. So it's going to go 5 plus 3 is 8, plus 3 is 11, plus 3 is 14. But if it was to try to add 3 again, it would get to a value that is larger than 16, so it doesn't. So it stopped because it already hit its maximum limit. As I said before, you can actually have negative ones. So if I want to go from 16 to minus 14 in steps of 9, I typed in the following line of code. I'm going to get an answer that is 16, 7, minus 2, minus 11. Again, it stops at minus 11 because if it was to take off 9 again, it would have a number that exceeds its limit of negative 14. So how does vector addition and subtraction work? So there's two cases we're going to look at. We have the case of a scalar and a vector. So a scalar is added or subtracted to each element of a vector. So if I was to define vectors v1, v2, and v3 as shown, and I wanted to define a variable d1 that I say is v1 minus 4, d1 is going to contain minus 2, 1, 5, which came from doing 2 minus 4, 5 minus 4, and 9 minus 4. All right. The second case is two equal-sized vectors. So if you have two equal-sized vectors, the corresponding elements of the two vectors are added or subtracted. Otherwise, an error occurs. So the first example we have is v1 plus v3. So S1 is going to contain 6 minus 2, 9, because we have S1 is equal to 2 plus 4, 5 minus 7, and 9 plus 0. If we were to try to add v1 to v2, you're going to get the error message, error using plus sign matrix dimensions must agree, because when it gets to the third element of v1, it's going to look for a third element in v2, which does not exist, so it cannot do that. We can have vector multiplication and division. A vector multiplied or divided by a scalar, what's going to happen is each element is multiplied or divided by that scalar. Dividing a scalar by a vector will produce an error, which means you're going to get some angry red letters. You cannot divide a scalar by a vector. A vector multiplied or divided by a vector of equal length, the corresponding elements are going to be multiplied or divided. So, in order to actually achieve this element by elements multiplication or division that we want, we actually have to use some special symbols in MATLAB, which are the dot multiplication sign and the dot divide sign, because if you were to simply use the multiplication or division sign, MATLAB is going to try and multiply or divide your variables, your vectors, based on the rules of linear algebra, which are slightly above the math level of this course. I am going to post appendices that do explain it. It has to do with inner and outer dimensions. You are going to be doing it quite a lot in classes that involve a lot of vectors, such as statics. So if you try to use the element-wise dot operator and you have vectors of unequal length, you are going to produce an error. So if we look at some examples of vector multiplication and division, again, I have my three previously defined vectors. I wanted to define a variable q1 as v1 divided by 5. It's simply going to divide each element in v1 by 5. I'm going to I have a variable that says p1 is equal to v2 times 300. It's going to multiply every quantity in v2 by 300. I define a variable of p2 is v1 dot times v3, which means I want to do element-wise multiplication. It's going to then multiply each element of v1 by its corresponding element in v3, so the first, the second, and the third. So you have 2 times 4 is 8, 5 times -7 is -35, and 9 times 0 is 0. The same goes if I define a variable q2 and I say I want v3 divided by v1. So q2 is going to contain the element by element division. So we have 4 divided by 2, -7 divided by 5, and 0 divided by 9. Some things that are going to not work is if I try to divide a scalar by a vector, you're going to get the error message that says error using the / matrix dimensions must agree. That's because MATLAB is trying to do matrix math on a 1x1 and a 1x3. And then we have, lastly, say we're trying to multiply v1 by v3 and we forgot our dot in there for element wise. It's trying to multiply a 1x3 by a 1x3, which isn't allowed for matrix math because something called your inner dimensions must agree, which is the error that it is giving you. So you have to be a little careful when you're defining multiplication and division in MATLAB, whether or not you actually want element wise or vector math. This course is primarily going to attempt to stick with element wise math. So let's look at another example. We assume we have variables n1 and n2 that each contain a single value, which is a scalar. We want to place the results of the calculation in a variable called ncalc, and the calculation we're trying to do is n1 times cosine of pi e to the -5 n2. So what are we going to write? Well, what we're going to first do is we're going to define our variable. We have our variable ncalc. It's going to be equal to n1, which is a scalar, times cosine, which is a function, times pi, which is a built-in function, times exponential, which is a built-in function, times -5 times n2, and we're going to close all of our parentheses. Make sure to keep track of your parentheses. MATLAB has color-coded them for you to make it easier. So since everything is a scalar, this is the basic line of code we would start with. But what happens if we change some variables from being scalars to vectors? So we want to determine g, given by the equation g is equal to bt times 2 pi over m. Well, in this case, b and m are scalars and t is a vector. So what are we going to write? Well, we have our scalar times our vector, so we don't need a dot, times another scalar. So again, we don't need a dot. So this is much like the previous example. However, what happens if this time t is what happens this time if t is a scalar and m is a vector? Well, here we have our scalar times a problem. We're trying to divide a scalar by a vector, which will not happen unless we put the dot sign in there, which then tells it to do it element by element. What happens if b and m are vectors? Well, in this case, we're going to have to account for some element-wise multiplication and division by saying it's now b times t times an element-wise multiplication of 2 pi divided by an element-wise division of n. You can think of rearranging this equation, because I'm not dividing a scalar by a vector because t is also a vector. So you can kind of move the 2 pi b to the outside of the equation. So how do we raise vectors and powers? So a vector raised to a scalar, we can have a scalar raised to a vector, we can have a vector raised to an equal size vector. So in all three cases, we have to use the element-wise operation of dot caret. and not the regular caret to tell MATLAB we want to do element-wise calculations. So to look at some examples, I have my 3 previously defined vectors. If I want to define a variable r1 and say it is v1 cubed, I want to cube every element in v1. I'm going to do v1 dot caret 3, which is then going to cube every element in v1. Say I want to take 2 and I want to raise 2 to every power in v3. And I want to do that element-wise, so then I'm going to have R2 contains, well, 2 to the 4th, 2 to the minus 7th, and 2 to the 0. I can also do V3 to the power of V1, so that's going to do 4 to the it's going to do 4 to the 2, it's going to do minus 7 to the 5th, and it's going to do 0 to the 9th. What happens if I try to do v2.v1? Well, again, I'm going to get an angry message saying that your matrix dimensions must agree because v2 and v1 do not contain the same number of elements. So let's look at another example. We're trying to calculate the flux of a light source based on the distance from the source, given by the equation phi equals lambda divided by r squared. We have lambda is equal to 2 and r is equal to a sequence of 0.25 and steps of 0.25 to 1. So we're going to write a code to determine the flux. We're going to get that it is phi is equal to lambda. Again, we have to do element-wise division to be able to divide our scalar by our vectors in each element. And then r, we want to square it, and we want to square each element. What happens if both lambda and r are vectors? Same thing. So assume we have the following variables. We have rho, we have r, we have h, and we have omega, and r is the vector, and we want to determine the kinetic energy given by the equation, where our kinetic energy is 1/4 pi times density times r to the 4th times h times omega squared. We have to make sure that we have our dot to the 4th here for r, otherwise everything else is a scalar and we don't need our element-wise operator. Technically you could put it in all the time to be safe, it won't do anything, but since scalars are 1 by 1s, they automatically get done element by element. So what are some useful vector functions? So all the functions previously listed, so sine, cosine, round, work with vectors. In most cases, they are automatically performed as an element-wise calculation. So if you do the sine of a vector, it will take the sine of each element in that vector. We also have length, which will find the number of elements in a vector, which is useful. We have find, it finds the indice values that meet some criteria. We have sort. We have rand, we'll carry to a vector of random numbers. We have the min and max, which will find the minimum and maximum and its location. We have unique, we have intersect, which will find the values of 2 vectors with, and we have union, which will find all the values of either 2 vectors. So if we look at an example, we wanted to generate 2 vectors, each containing 10 randomly generated elements whose values can vary as follows. We want the first one to vary from 1 to 450, and the second to vary from minus 500 to 0. And the 2 vectors, and then we want to add the 2 vectors and determine the value and location of the maximum element in the summation vector. So first we have to define our variable v1. To define that, we would have randy of 450 is our max. We want it to go from start at 1 and go in steps of 10. We don't have to define a minimum because it defaultly starts at 1. And for v2, we want it to go from minus 500 to 0. So the first input is the range that we want, and then it is our steps. To find the maximum, the location of the maximum and the maximum, we're going to define a vector ml, so it's going to store the values in m and then store the values in l, so this is going to be the max and then its location, equals the max of adding the 2 vectors together. So let's look at another example. We want to write a code to determine the minimum value and the location of A and the total number of elements in A, and we want to store this variable in A min, which has the value, column, and then the number of elements. So first we have to define our vector. We're going to define a variable v, which is the minimum of A. Then we're going to define another variable c, and we're going to tell it to find where v is equal to A. Double equal sign logic means equal to in MATLAB. Then we're going to define another variable L, which is equal to the length of A. And then I'm going to actually finally define a min, which is equal to our vector C colon V colon C colon L, because you can define vectors in terms of other vectors. Alternatively, I could have defined two variables at once using a vector VC is equal to the min of A, which will automatically find the minimum and location. And then I define the length of A, and again, then I define a min. One more example, we're trying to write a code to determine g, where g is given by e to the minus mt divided by the cubic root of b plus 5. Since everything is a scalar but t, we don't have to worry about our element-wise multiplication, and our exponential function automatically works on each element of t. So there's nothing more that we actually need to do besides just typing in the equation into MATLAB. So how do we combine vectors? I did a little bit of this in the previous slides. We can combine by simply listing them in the desired order inside of square brackets. Rows, again, are separated by spaces or commas, and columns are separated by semicolons, and you can use the apostrophe to transpose as needed. So if I wanted to create a combined vector of v4 and v6 in the order of v4, v6, first of all, I had to transpose v6 because v6 was a column vector, not a row vector. After I do that, I'm going to get a variable vc containing first v1 and then the transposed version of v6. So we're going to look at another example. So we have assumed the variables above, we already defined them. We want to know the outcome of the following line of code. Basically, I want to define a variable v, and in that variable v is going to be vector a and then vector d. This code works. It's going to give us a 1/6 vector, and it's going to be the values of vector a, which is 1, 0, minus 1, followed by the variables of a vector d, which is -2, 5, 1. If I did a colon d, what's actually going to happen? Well, it's going to put a in the first row and then d in the second row, so we actually wind up with a 2×3 matrix. If we try this one where w is equal to b colon c, well, first of all, b is a 2×2 matrix, c is a 3×2 matrix. We're going to a 2×3 matrix. We're actually going to get a 5×2 matrix. MATLAB does rows then columns. So what happens if I try to put B and C next to each other? Again, remembering that B is a 2×2 and C is a 3×2. What's going to happen is you're going to have an error because the number of columns doesn't agree. And I had defined a row vector here, so it needs the same number of columns. Sorry, you're going to get an error here because I defined a row vector and they do not have the same number of rows. So vector indexing is very useful to retrieve individual elements from vectors. So what if I wanted to perform a calculation on a single element? We have indexing or addressing, which allows you to call a specific cell within a vector. So if I want to place a numeric position of the element you want, we place it in parentheses after the vector name. So say I wanted to get the second element of this vector, 5, which is the number 5, I would say v1 in parentheses 2. That's telling me I want the second element of v1, which is the value 5. Index values must be integers and are strictly positive, so you can't have a 2.7th element and you can't have the -3rd element or the 0 element actually, because MATLAB starts counting at 1 since it's counting rows and columns in a matrix. MATLAB auto creates rows and vectors. Row vectors, undefined values are set to 0. So if I define a variable v1 of 7 equals 10, it's going to create the first 6 elements to be 0. You can also use indexing to change values. Say I have the vector v7, it's a column vector of 3 minus 7, 34, 0, 8, and I want to change that 34 to a -1, so I want to change the third element of that vector to a -1. If I type the line of code v7 of 3 equals -1, v7 will now contain a column vector of 3 minus 7 minus 1, 0, 18. You can also use it to delete values from a vector. To do that, you insert empty brackets. So if I had a variable v8 and it contained 2, 1, 5, 8, 6, 3, and I wanted to delete the third element, I would say v8 of 3 is equal to an empty bracket. It's going to remove it. It's going to delete the third element, so now v8 contains 2, 1, 8, 6, 3 because I got rid of the third element, which was a 5. You can specify more than one element. You can list indices of wanted values in parentheses as a vector in square brackets separated by commas or spaces. For example, if I have a variable v9 and it contains 3 minus 2, 5, 0, minus 7, and I want to replace the second, fourth, and fifth elements with the value of 99, I would say v9 of, in brackets, 2, 4, and 5. So I have, for multiple indices, they go in as a vector. So v now contains 3, 99, 5, 99, 99. You can also use it for linear sequences. So if I have a variable cv7, which is 3 minus 7, 34, 0, 18, and I type in cv7, sorry, that should be 7, of 2 to 4 equals 99, it's going to replace the 2 to 4th element with 99. So C7 now contains 2, 9, 3, 99, 99, 99, 18. You can do a calculation on part of a vector. So I want to determine the sign of the fifth element of a vector t20, assuming the values of t20 are given in radians, and place the result in S5. So I can say S5 is equal to sign of t20 of the fifth element. You can try to do a calculation on an element that does not exist. You will get an error that says the index exceeds the array. So let's look at another example. We have these predefined variables in MATLAB. We want to write a single line of MATLAB code to perform the following operation. We want to create a 5-element row vector named M, in which the first 3 elements are the 3 elements of A, and the last 2 elements are the second and third elements of D. Well, what are we going to do? Well, M is going to be equal to, well, first A, because we want all of A, comma, then we want the second and third elements of D. D is actually, so D is a column vector, so this is the rows and this is the column. If you don't put the column in, MATLAB might get a little confused, and then I have to transpose it because it was a column vector that I need to turn into a row vector. Another example is what's going to be stored in B following the execution of the following code segments. So we have A is equal to 3 minus 4, 0, and I want B to be equal to 2 colon 3. That means I want B to be equal to the second and third elements of A, so B is minus 3 minus 4. So that's it for vectors. In the next lecture, we'll go over matrices, which is just going to expand the number of rows and columns we can have. So if a scalar was a 1-by-1 matrix, a vector was a 1-by-n or an n-by-1. Matrices are going to be n-by-n. With matrices is when things become also very complicated, because we also have to make sure we're doing our calculations correctly on an element-wise basis or in a matrix math basis.